Good evening, ladies and gentlemen. It's indeed my proud privilege to stand here and talk about target acquisition with special reference to aerial targets. Before I start, I wish to thank Chair and the organizers of this seminar for giving me this opportunity to come and stand here and give my views on target acquisition in the modern day battlefield milieu. Getting down to business, this is how the talk is going to be structured in basically three broad heads. A talk of the air threat, which has been spoken of by the General also in quite details. So I'll rush through this. Then I'll come to the challenges in acquisition of aerial targets and the methods of acquisitions and what the future has in store for us as far as aerial target acquisition is concerned. Coming to the aerial threat, actually the air threat has revolutionized in such a fashion that its study has to be continuous. Only then we can be ready to tackle it and devise means of acquiring these numerous and novel aerial objects which are sprung by the enemy on us and be ready to neutralize them also. I think it's quite evident the aerial threat has manifested in the most modern fashion. It's in the 5th generation now. It started with the bombs being dropped by hand in the First World War, and it has progressed to the 5th generation fighter aircrafts and UAVs, etc., which are now in vogue. Coming to the fighter aircrafts, as I said, they are already in the 5th generation mode. There are stealth fighters available. The modern fighters are very, very robust. They are survivable. They are survivable structurally as well as electronically. They can defend themselves against whatever you wish to throw at them, to neutralize them, and our aim is to overcome this defensive suite which it carries. Till now, actually, the air threat was is just rotary wing and fixed wing. But now, what is happening is, over the ages, the unmanned threat has been on the increase. The ratio of the aircraft, that is both fixed wing and the rotary wing, have been coming down, as you can see from this graph. And the UAVs and the surface-to-surface missiles, they have been on the rise. And we'll see soon as to why it is happening. The reason is very simple. The unmanned aerial vehicle does not expose a trained pilot to enemy fire. It is the unmanned vehicles, the surface-to-surface missiles, the UAVs are much cheaper compared to a fighter aircraft, and hence the focus towards low cost, low risk, high payoff aerial platforms in terms of missiles and UAVs. The attack helicopters, they inspire shock and awe in all of us. We have seen Rambo movies and other movies also. We've seen the videos of the Gulf War. The attack helicopters are now all-weather. They can fly at night, navigate by themselves, they can fire at night. They have a lot of electronic warfare suites on board. They can carry a number of types of weapons as against the earlier ones. And they are moving towards stealth, both against the radar sensors as well as acoustic sensors. The modern day helicopters are being designed so that the radar reflection is suppressed and the acoustic are also suppressed, and even the infrared signature is suppressed. The next is the UAVs. This is one field which has led to the paradigm shift in air threat. The development of UAVs started with just UAVs for surveillance means, but the capabilities have grown many folds today. They are being used for target acquisition, target acquisition of surface targets. They are also being used for post-strike damage assessment. They are also being used for strikes. The drone strikes in the northwest frontier province of Pakistan and Iraq and Afghanistan. We read about it every day, and these are nothing but unmanned vehicles, combat vehicles which are carrying missiles and carrying out strikes. And the UAVs, there is a whole lot of them available. They are from small size to large size. They have endurances from a couple of hours to even 24 hours. The ranges from a few kilometers to thousands of kilometers. The strikes in Afghanistan, Pakistan are carried out from Midwest United States using SATCOM. That is the kind of developments we are seeing. These are the latest UAVs is the X-47. You see it on the slide now. It can be brought down on a carrier. It is so difficult to land a UAV on a static runway. Imagine landing it on a moving carrier. So carrier-based UAV operations are also a thing of the future. And these UAVs actually are are increasing the problems for the air defense warriors. They are tending to be smaller in size. They are getting stealth techniques incorporated into them, so detection is very difficult. They are very survivable also. They are very maneuverable due to the slow speeds involved. They can just turn around and evade the weapon system which is launched on them. That is the kind of problem which is manifested due to these UAVs. Next are the precision-guided munitions. We are all aware of the laser-guided bombs. We heard enough of it during the Kargil conflict. We also have the GPS bombs, which are used extensively in the Gulf War too. Now these weapons, they used to be released from a few kilometers. Now we have weapons which are being released from hundreds of kilometers, which is increasing our problems. These weapons are smaller in size. They are very, very precise, very accurate, and the collateral damage which they cause is very, very less, which increases their attractiveness for the enemy. Ballistic missiles is the next type of air threat vehicle which I'll talk about. They are also they have become very, very accurate. They can carry a wide variety of warheads ranging from conventional to nuclear. And they are getting proliferated by the day. Even non-state actors are trying to get them, and once they get them with nuclear weapons, I leave it to your imagination to try and understand as to what kind of a world we'll be living in. Next are the cruise missiles. Again, they became popular after the videos of Tomahawk missiles taking off in the Gulf War were telecasted the world over. They are a very, very low-cost option. As I said, one aircraft versus 40 cruise missiles. Not necessarily Tomahawk, there are other cruise missiles available. Not only the developed nations, but even developing nations are acquiring them. Even we are going in for our indigenization programs as far as the cruise missiles are concerned. Again, they are very, very accurate. They cause very less collateral damage, hence they are a very, very attractive option. So now what are the takeaways from whatever I have talked of? There is a multiplicity of threat vehicles which we have to engage. Stealth technology is adding to our problems. UAVs, UCAS, as I told you, are again adding to the problems. And munitions, that is precision-guided munitions launched from hundreds of kilometers, make it imperative that we start treating munitions as the threat vehicle and not the carrier or the launching vehicle of these munitions as the target. We have to target the munitions themselves. And the munitions, as I said, are small sized, very fast moving, and it is a problem to engage them, but they are engageable. The ranges are increasing, both of the munitions as well as the aircraft, and electronic warfare and cyber warfare are being used extensively to try and evade the acquisition techniques and the weapon guidance, etc. Cyber warfare, I'll just introduce you to this aspect. In 2007, September 2007, Israel raided and destroyed a suspected nuclear strike in Syria. Now the Syrians had a very, very extensive and modern air defense network, and they just didn't have a clue as to what happened. It is believed that cyber warfare was the culprit, because electronic warfare, if it is used, what happens is the effects are visible to the air defense warriors in terms of jamming of the scopes or some deceptive targets appearing on the scope. Over here, nothing was seen by them. The Israelis came. It is believed that 8 to 9 aircrafts were used, out of which 4 entered the Syrian airspace, carried out the deed, and they went back undetected. Only the guys at the nuclear site, nuclear installation site, who bore the brunt of the strike, they came to know as to what is really happening. The rest of the world didn't know. So what are the challenges in acquisition of this thing? We will see that. What is target acquisition? Target acquisition is you are carrying out surveillance, you detect something. Now you have to decide as to what you want to track, identify, and ultimately destroy. So I limit myself to just to detect the target, identify it, that is target acquisition. I limit myself to that. The imperatives. We have seen the family of air threat vehicles which are being sprung, which are capable of being sprung by the enemy. So we require a very number of diverse sensors are required. We should be able to pick up targets at enhanced ranges, and we have to shift towards passive means due to the electronic means which are available to the aircraft, and even the anti-radiation missiles which the aircraft can carry. We need to exploit a number of technologies. Only then the stealth techniques can be overcome, the small size targets can be detected. There are multiple sensors which add to the problem. So you have to fuse this data. The previous speakers have been speaking about data fusion, and you have to incorporate GIS technologies in order to obtain a comprehensive air situation picture, a recognized air situation picture, along with the fact that there should be no duplication of targets. It's a major challenge. And coupled with this data fusion, if you have slew queue facility, that is, you just queue the target, weapon systems onto the target, you cut down on time and engage the target before it can do any damage. Redundancy is required because of electronic warfare and cyber warfare with techniques which can be employed by the enemy, and you have to carry out real-time processing because the targets are very fast moving and they have to be engaged before they do the damage. So what are the methods of target acquisition? This is there. I'll just go over them one by one. As far as the radars are concerned, multi-band and phased array radars are the in thing today, and they will remain for the future also. Multi-band to make them robust against electronic warfare. Phased array, because you don't need to physically move the antenna. Electronic beam steering is enough to carry out surveillance of the entire airspace. The beams can be very, very pencil thin, and they can overcome stealth techniques. They can be immune to jamming because of the pencil beam. The side lobes suppression is near perfect. As a result, ECCM is ensured, and they can help in detection of the UAVs. Multi-static radars, very, very effective. Bi-static radars is one receiver, one transmitter. But in multi-static radars, you have a number of receivers. And this is what helps us in detecting stealth objects. We also have ESM-based sensors, which is the offshoot of passive sensors. What happens is, over here, ambient radiations in the atmosphere are used by what was designed as ESM, electronic support measure equipment, signal intelligence equipment, but now they have been modified, upgraded to carry out target acquisition. They have got very long ranges, they are very, very accurate and will be a preferred option in times to come. Passive sensors are talked about. Acoustic sensors. Acoustic sensors were used initially when the air threat started manifesting itself, and they are back again like everything. You know, the old fashions go away and they are back. Light is nothing but an electromagnetic radiation. I don't need to educate this august gathering. And microwave radiations and high frequency or super high frequency radiations are used in radar. Similarly, light beams can be used, laser can be used in something called LIDAR. This has been there for quite some time, and this is again an application for the future. Next comes the electro-optical systems. They are systems with day cameras, night cameras, signal processing units and guidance units, which are very, very prominently being used in short-range weapon systems. You have the radars acquiring the target, and they just slew the electro-optical system onto the target for further engagement. And multi-sensor fusion, I will not dwell on it. I think we have spoken about it enough. To conclude, I have tried to put in perspective as to what are the challenges sprung by the air threat and what do we have to overcome for meaningful target acquisition. And passive sensors, the light, cellular radiations being used in CELDAs, they are the things of the future in case we have to remain in the business of air defense of the country, and we have to start acquiring these modern systems in case we have to remain in the game and counter the enemy air. Thank you.